Okay, good morning, students. I do believe you guys are doing great. Today we're going to have another lesson in chemistry. And, we're still looking at bonds. I remember last time we finished off with ionic bond in class. So we were looking at the ionic bond. And they said ionic bond is a word which is made from the word ion, sorry. It's from the word ion. And then you just have ionic to make it an adjective. And, sorry about that. We said that ionic bonds, these are bonds which exist between a metal and a non-metal. A good example is a sodium and a chlorine atom. And we said that there is an involvement of an electron transfer, whereby the electron for the metal is transferred to the non-metal. All this happens just to make sure that both atoms are stable or fully filled in their shells. All right, now let's move on to today's topic. Oh, and also remember that we looked at ionic compounds. Okay, all right. And we said ionic compounds, these are compounds made from a metal and a non-metal. A good example is magnesium oxide, which is made from magnesium and oxygen. We also have magnesium chloride, which is made from magnesium and chlorine. And in this case, if it's a magnesium chloride, it simply means electrons will be transferred from magnesium atoms to the chlorine atoms. So the chlorine, which is a non-metal, will receive the electrons, and the magnesium, which is a metal, will lose the electrons. Okay. And we have some questions. It says, draw a diagram to show what happens to the electrons when a sodium atom reacts with a chlorine atom. All they want you to do is just to draw this diagram here, like in the example of magnesium chloride, to show that the electrons will be moved from the sodium to the chlorine. That's what they want. If you go to 2, it says, what is an ionic bond? Oh, it's a bond which exists between a metal and a non-metal, or it is an electrostatic force of attraction which results in the transfer of electrons from metals to non-metals. Whatever way you can put it, as long as you talk about a metal and a non-metal. Then we have question 3 says, describe in your own words the structure of solid sodium chloride and explain why its formula is NaCl. Now for that one, they're talking about a solid structure, solid sodium chloride structure. For that, let's look at the structure of ionic compounds. We said they form a lattice with alternating positive and negative ions. So as you can see in this example, you have a lattice and you have those alternating positive and negative ions. So you have a positive ion, then it's surrounded by negative ions. You have a negative ion, is completely surrounded by positive ions. Now, if you want to draw a lattice of sodium chloride, so it means instead of drawing the plus signs, you're supposed to put the Na plus. So the Na plus, that's the positive ion of sodium, and the Cl minus would be the negative ion. So it will be Na plus and the Cl minus to show the alternating positive and negative ions. Alright, then today we'll focus on covalent bonds. We'll talk about the covalent bond. Now, covalent is a compound word which is made from two words, co and valent. Co means sharing and valent means outermost. Okay, now what happens then for you to have a covalent bond? All you need for you to have a covalent bond is two atoms, two or more atoms, but for the meantime we'll talk about two only, which are non-metals, all of them in nature. Then these ones should not really transfer electrons, rather they should just share. Alright, I'll give you an example. Some other times, okay, let's say you have a friend who has 2,000 kwacha and you have 1,000 kwacha and a plate of chicken, sort of the whole plate just filled with chicken, is selling at 1,500 kwacha. So your friend can just take 500 kwacha and give it to you. Alright, and then your friend will be able to buy a plate of chicken, and you also be able to buy a plate of chicken Yeah, that's what happens with ionic bonds. This is whereby they transfer electrons from one atom to another. But for covalent, I'll give you the same example. This time, okay, let's say that your friend has 1000 kwacha and you have 500 kwacha. Now, if your friend gives you the 1000 kwacha, yes, you'll be able to buy the plate. But by the end of the day, your friend will have nothing to eat, which I don't think really meets the whole purpose of sharing, of giving one another money. Because you don't give money so they should be broke by the end of the day. I don't think so. This is the understanding of all atoms as well. They know that. Now, in terms of sharing, what they do is they say that if this atom loses its electrons to make the other atom stable, it simply means that atom which gave out the electrons will be completely broke. It will have a shell which is not fully filled, which will be a problem. So what they do is they share. I'll give you a very basic example of a hydrogen and another hydrogen atom. This is a basic example of a covalent bond because hydrogen is reacting with hydrogen and both are nonmetals. Both hydrogen and hydrogen are nonmetals. Now, you can see that the hydrogen on the left has one electron in the outermost shell, and the hydrogen on the right also has one electron in the outermost shell. Now, if you take this into consideration, you can see that the one on the left needs only one electron to be fully filled, one more electron, yeah? And the one on the right also needs one more electron. All right, now what they do is they know that if the guy on the left gives out that electron, then it means the one on the left will have a shell which is not fully filled, which will be a problem. So what it does is the two guys just agree to say we both have electrons which can make us fully filled. Let's share these electrons. So they will bring together the two electrons. The two electrons will be flowing in both shells. The shells will overlap like this on the right, as you can see in this diagram. So the two electrons are flowing in both orbiting both shells. Thereby, they have shared that pair of electrons. Another example is when you have a chlorine atom. Right here. So, chlorine has 7 electrons in the outermost shell. Now, what happens is when chlorine reacts with chlorine, they can't transfer electrons. Rather, what they do is they will just share one electron. So, by the end of the day, one chlorine atom has 8 electrons flowing in it, and the one on the right also has 8 electrons flowing in it. So that's what purpose about sharing. Now let's look at single, double, and triple covalent bonds. Okay, a single covalent bond has a pair of electrons being shared. This is different to a single ionic bond. A single ionic bond involves one electron being transferred, but a single covalent bond involves 2 electrons being shared. A double covalent bond involves 4 electrons being shared, as you can see in this example of an oxygen molecule. And a triple covalent bond involves 6 electrons being shared. That being said, I want you to do this exercise 1, 2, and 3. Otherwise, have a good day. See you in the next lesson.